Hi, everybody. Welcome to the lecture series. I am excited to introduce our speaker for today. Just a reminder, we do have a lecture next week. Next Monday will be Sarah Rule Bergeron, who just joined our faculty this semester. November 6th will be Belmont Freeman. And then November 27th will be Laura Del Pino. But now for our speaker today, Andreas Theodoridis.
Perfect.
I don't think that was perfect. That was kind.
Perfect.
Is a practicing architect, engineer, and environmental technologist with a PhD from the Center for Architecture, Science, and Ecology, a research center of Rensselaer Polytechnic Institute based in New York City, and a research collaborator at the Yale Center for Architecture Ecosystems. His research is interdisciplinary, merging 25 years of experience in building construction and fabrication with applied research on building systems and environmental initiatives on an urban scale. His current work focuses on hybrid air, phytoremediative modular ceramic systems for building envelopes relative to questions on environmental inequality. He runs the experimental design practice United Atmospheres and is currently an assistant professor at NYIT. Thank you so much for joining us today.
All right. Let me see why we can do that. You said up and down?
Yep.
Thank you all so much for coming here. Thank you, Stephanie, for your kind introduction. I'll do my best to I guess, express some of my thoughts into this audience and hopefully maybe educate a little bit the students or the community in the subjects around air pollution and air quality and inequality. I guess, as you described, I have an interdisciplinary background. And so I think I'm going to focus my presentation in two distinctive sections, before 2012 and after 2012. And the reason why I'm going to do that, I guess, let's see if I can get this thing starting. Up and down doesn't work for me. I might be doing something wrong. All right. So do I see the next one? Okay, so it's going to be on the screen directly. So I'm going to mostly focus in between two different sections, in between 2012 and 2012 and after. And the reason why I will do that is because I was mostly focusing on different parts of my work. Before 2012, what you see is me being one of my construction sites, the guy there overlooking some of the metal reinforcement bars, trying to do a couple of buildings in Greece, where I'm originally coming from, different types of buildings, nevertheless with all the necessary details and drawings, buildings like houses and officing units, under circumstances that were great and some of them that they were not so great, having injuries and things, but nevertheless still on my construction sites, trying to supervise some of my projects. Small or bigger size innovations, smaller size or kind of bigger size projects, different materialities, different kind of research questions, mostly focused in terms of use of materials, materials in terms of how we recirculate, upscale materials, upgrade the kind of intention that people had before they produced this kind of materials into a different type of typology for the building section. Here you see a project that I was reusing existing wood floor, partially kind of compensating the rest of the surrounding floor area with a new tile type after I demolished some of the walls, gut renovation for a sixth floor, last floor building in one of the periphery cities of Athens. Also introducing back then a system that was not quite kind of popular to this kind of typology of buildings. A heat space, a heat device that was heating all the house and the water pipes of the systems through the burn of wood. Everyone was laughing at me back then, getting this thing into the sixth floor with a crane from outside into the balcony of the building inside and so on. But nevertheless, also experimenting with different kinds of constructions, different typologies of workshops and things, like the one that you see here back 2013 or 14, if I remember well. A Studio X, the global program of Columbia University with studios overseas. This one took place in the island of Crete, where we were investigating with different media the life and materiality that could be a new kind of contemporary type of a labyrinth on the same island the labyrinth was invented a couple of thousands of years ago. And of course, you can see many more, I guess, projects of this individual or a little bit more 2012 kind of professional life that I had as a practitioner into my online portfolio, and soon maybe into my website if I manage to finish the back end of this, which I'm going to explain a few more things at the end of this lecture, I guess. And so after 2012, I'm going to read you a quick statement, I guess, from what we see here. It's a report of the 2012 World Health Organization, estimating that 7 million premature deaths annually are linked to air pollution, characterizing the adverse effects of air quality on the difficult to read with the screen. It's a good thing that I have here. Air quality on the human organisms as the world's largest environmental health risk. And as a coincidence, the same kind of year in Greece, things are turning really badly in terms of air quality. The IMF is coming to the country. They impose a new tax into the heat oil of the buildings. People start burning alternatives to the heat oil. They start burning byproducts of wood and making impromptu stoves and furniture that they were not using back, and plastic kind of reinforced wood from the streets and pallets and things like that. And the atmospheres that you see in Greece, it turns this way. During the day, it's not so visible, but during the nighttime, everything is quite toxic in the atmosphere. You get into your car in the morning, everything smells awful. You don't realize that that might be toxic back then, but you realize that something is wrong. And then me standing there as an architect, I have no idea how to deal with these kind of problems. And that was more or less led me into the rest of my studies and the 2012 afterlife, trying to study the space even further, doing my master's degree at Pratt, and going through the Urban Sustainable Environmental Systems program, teach for a couple of semesters at Syracuse University Advanced Building Systems, but always in relation to questions in terms of air quality, air pollution, air handling systems, as you can see here. And then further moving into my PhD at Case, starting to questioning things about mechanical systems, how we ventilate space, how they are related to the overall volume of the buildings, what kind of effects they have in terms of how we are handling air from the outdoors to indoors, and why we consider in the discipline that we're dealing with two different things, like the outdoors and the indoors, what kind of envelope systems we currently use, how we describe them, what kind of functions they have, why they have to be so linear kind of addressed, that they only function in individual aspects, like the energy reduction or the air handling or the kind of glare conditions, or can they maybe function in multiple layers? Can we reinvent a kind of a type of envelope? All these were questions that I had not necessarily the experience to reply to them, but I was trying to figure out if I can navigate around the subjects in a more profound way, I guess. And so in parallel with my PhD studies, I was also, since I had this kind of practitioner's background as well, I was helping with other studios at RPI, dealing with materiality, how things are coming together, different types of materials that I haven't used before. What you see here is coming from a company that's called a company that was trying to create this new type of bottles that they're not going to be end up in a landfill, but they're going to come together almost like a jigsaw, like a kind of Lego piece, building to each other. Everything that you see here is self-assembled. There is no glue, there is no adhesive, there is nothing else that you can see. It's these bottles standing alone. Trying to investigate how this kind of new approach from the Friendly Bottles company could be maybe a solution for regions of the world where they might have some sort of a catastrophe, a war zone or some sort of earthquake or a hurricane or something that would be there, and then we'll need to be able to address these kind of questions and maybe help the people a little bit by sending this kind of equipment. So they're using what is inside the bottles, and then eventually they turn them into these shelters that they can shelter for the first few days before everything else is getting place. And of course, the questions that I was having around this subject were not only questions in terms of materiality and the kind of relationship of things, how they get together and such, but it also questions about the scales inquiry. What would be the scales of interventions of the systems that we're looking for? Would it be scales of global, would be urban scale, would be a building scale, room scale, micro scale, or even nanoscale, since we are talking about air pollutants? And I guess moving forward with these kind of questions, I was trying to analyze all these problems into different scales as well. What we see here is mold as viewed under different scales. Mold as we know it, or we shouldn't know it, from the interior of spaces, and mold as we see it magnified, and then mold as it magnified into the micrometer scale. It looks interesting. It might be one of these nice parametric drawings that you get out of Rhino, right? But in reality, it's the same thing that we see in the wall in an entirely different scale. And so I was trying also to teach myself and educate the rest of the community. And the slides that you see now, it's from my last year course at GSAB. What kind of scale are we talking about when we talk about air pollutants? We keep talking about micrometers. Usually, pollutants, the highest size of pollutants that we see in our environments are particulate matter 10. And that means particulate matter at the 10th of micrometer. What you see there is the size of the coin, the dime that you saw before, particulate matter 10. What you see is a sand, a bit sand, a fine particle, which is 90 micrometers in diameter, in the size that it corresponds to the coin. And then what you see around the sand, the blue kind of spiky pieces, are particulate matter 10. The red ones are particulate matter 1. And all the obnoxious pollutants that we're trying to find into our built environment is way below what you see there, the red spiky things. So you get a sense of what we think that is invisible. In reality, it has a substance, it has a physical size, it has physical qualities, and we need to figure out ways that we can deal with these kind of things. And then I was trying to investigate as well, what do we measure in our current environment? What is considered pollutants? We know about particulate matter. We know about, I don't know, NOxes and all these other pollutants that EPA, the Environmental Protection Agency of the States, United States, is measuring. CO2, though, it's not considered a pollutant. All those studies recently have showed that even in low levels of 600, as we probably have inside here this time, in this space, they have cognitive function effects to our brains. They make you feel a bit more sleepy, they make your brain function slower, they might make your brain not being able to concentrate as clearly as it is, but nevertheless, we not consider it a pollutant, because it doesn't kill us instantly, I guess. It needs to take a few more years. Also, I was studying things around microplastics. Nobody's considering, pollutants anymore. Although, now with the advent of the electric vehicles, they are emitted in higher grades into the atmosphere than the regular pollutants that we were talking before. And the reason is because electric vehicles have these batteries, they're heavier. It means that the kind of friction that cars they have in their street pavement is higher, and then every time that you use your tires, they degrade in higher rates, which means that we have higher kind of concentration levels into the atmosphere. What you see in this kind of transparent boxes over there is what the car tires emitting in a day from different types of vehicles in London. Now they seem concentrated and harmless, but imagine if all these things are getting into your lungs while you are walking in the street next to a bus or a car, right? And so the idea was that I need to study further these things and how we deal with these kind of questions, how we start understanding what kind of filters we are using in our buildings, what kind of equipment we are using, how we are trying to deal with these kind of air pollutants. and do comparative studies and study the filters that we consider more regular to the ones that they are considered more upgraded, the ones that we're using in medical labs and kind of clean room spaces, like kind of the HEPA filters, the high efficiency filters. And I can tell you fascinating stories how the military army of the States was thinking that after a radioactive incident, they're going to be able to get with bulldozers and HEPA filters to clean the cities, and that's why they invented these filters. In reality, though, they don't do much except for reducing some of the bigger size kind of particles into the atmosphere. And I know that it's a little bit daunting, but I can verify it also with research work I was doing in my PhD. And what you see here is a diagram that it tries to synthesize all this information that I was talking before about environmental heat risk factors with the characteristics of the particles, the ambient air pollution standards, and then define how all these things affect our physiology as human beings, although we shouldn't only be concerned about human beings. And the interesting thing that you can get eventually, if I'll show you this diagram more clearly, is that different agencies in different parts of the world, they measure air pollution with different metrics and scales. And that is mostly associated with socio-political values. It's not purely scientific. It tries to create a narrative mostly about how clean the air atmosphere could be in these places without disturbing the industry of production. And so in China, for instance, you're going to see some of the highest end pollutant levels just to make sure that they get below these levels and everything seems to be clear. But this is not the reality. And furtherless, all the voids that you see in this table there, they are actually voids, voids for measurements and standards that they don't exist in these agencies, which is a huge problem. Not only they alter and they kind of manipulate what is considered pollution, they also don't measure a lot of them. And whenever they do, they don't measure them in a synthesis of what we understand as air pollution into our environments. We don't breathe air pollutants in isolation. We breathe them in a mixture of different pollutants, but we still measure them as being isolated in the environment. And I'm not going to focus too much in this diagram because it's very complicated, but the one thing that you might need to focus is that the man-made pollutants, because they exist also natural-made ones like volcano aces and pollutants coming from forests and things like that, they are one that they are smaller in size, physical size, coming out of incomplete combustion more probably, and the more lethal one as well. And just to give you a sense what I mean lethal, air pollutants these days, they don't go through your respiratory system into your bloodstream. They can go directly through your soft tissue to your brain. So they're not going to even go through your respiratory system to the rest of your body organs. They're going to travel directly to your brain, affecting your brain function if they are small enough. And I'm sorry for bringing all this daunting information to you. I'm just trying to make sure that we get a kind of perspective about the things that we are talking here. I was also terrified, and I'm trying to find solutions. That's the good part, I guess. And so I've been studying buildings, as I said. And I've been hearing about all these things about, as I said, big planned auditoriums like this, that they have mechanical systems in there. Why do we need mechanical systems? Why don't we have ventilated spaces, natural ventilated space? I'm coming from Greece, where windows barely close during the summer, not to mention even the winter sometimes. Why people need all these kind of systems for their spaces? And I was trying to study energy patterns in between mechanically ventilated buildings with natural ventilated buildings. And as you can see, in certain instances, you can have almost a 60% reduction. And that was striking to me. And I was thinking, well, why in the States they don't have operable windows anymore? Which is another question, which we can discuss later on. But I guess it was a very weird experience for me when at some point I ended up in a hotel in my first years that I was in the States. Amazing scenery, the hotel room was amazing, the lobby was great, everything was smelly nice, and you could hear all the spring sounds from the outside when you enter in the building, and then you enter in, and everything was in isolation. No operable windows, no humidity, no smell, no noise, no nothing. It's like, maybe my room would be different. After all, this was Hamptons. I was there for a visit with some friends. I went to my room, and then guess what? Nothing was opening. And that was the point that I started feeling weird. That something was off there. I couldn't realize at that moment. That was back in 2012, maybe. But something was off. And then I was trying to figure it out. And so I was also trying to predict if we have to alter this kind of mechanical to natural ventilation approach, where could that kind of technologies be implemented in the future? Because we have the current building stock that's going to be a little bit more difficult to adapt. What about the new building stock of the future? And so I created a series of maps that they were trying to define how we're going to get to realize where the problem currently, where the world population is going to keep growing, and then where they're not going to have enough money to pay for mechanical systems. Not because they're going to be a society that is not going to be able to afford mechanical systems or underprivileged, but because I truly believe that in spaces that they're renovating or they're starting or whatever they call developing economies, they can set a different paradigm, start thinking differently from what we already know that the existing markets have reinforced into the built environment. And so I developed more detailed diagrams that they were about all this almost Venn intersection approach, trying to realize all of these things happen through Köppen diagrams, World Health Organization diagrams, maps, data, GIS analysis, into 1 by 1 kilometers analysis, getting into numbers of where all these things are going to happen. But the important thing is that I was trying to develop part of my work as a PhD, how we move away from mechanical systems into what I was calling back then soft strategies. And so what soft strategies would mean for other people, I guess it would mean maybe self-balance systems, evolutionary, metabolic, maybe biologically sophisticated, non-linearity, heterogeneous, and we can go on about how other people were defining soft versus hard, but the main idea is that we needed an entirely different type of system. And that's what you see here. It looks like one of the regular green walls that you might be able to recognize from restaurants around you or other places, which is becoming a hit these days. But the one that you see here, it has also a back end. The one that is placed here is actually in the Public Safety Answer Call Center 2 in Bronx. The first one is, I believe it's somewhere in Brooklyn, but the one here is in Bronx. It's a building that was developed by SOM. Back then, as I was saying, the program I was doing my PhD was a hybrid program in between SOM and RPI. We were stationed inside their SOM office in Wall Street, being the research department. And so whenever they had a project we co-developed, we were developing with them. And this is a functional green wall. And what I mean by functional, I mean an active green wall that uses energy to drag air through the rhizosphere of the plants in order to ameliorate some of these pollutants. And so this is what I mean by air pollutants and phytoremediation. We know that the plants already reduce some of these pollutants through the leaves, but what we found after NASA research 20 years ago is that the rhizosphere of the plants, it actually does a much better work by a magnitude of 200 mostly, depending on the plants that you are using, and most importantly, the microbial community that surrounds this rhizosphere. The only problem is, guess what? The rhizosphere is inside the soil. So how do you drag air through that? And I guess that's where the green walls that we are working on come into play. They are more or less what you can describe as a vertical hydroponic system. It sounds nice and easy and very, not anything major to achieve, but then plants are living organisms, which means that you need to regulate the humidity, the lighting conditions, the circadian rhythm, what kind of microbial communities eventually they're going to evolve there, the typology of the system, and keep them alive. It means that it's not a mechanical system that you might be able to, or might need to maintain every year or every 6 months, or I don't know, and then switch on the power button and everything performs. Here we are talking about sensitive systems that they have all sorts of other attributes that you need to maintain. Important factor, important thing to consider when we are talking about this kind of systems. If we start evaluating them in comparison to HVAC system with the metrics that we currently use for mechanical systems, they underperform. If we start though using more inclusive metrics, like biophilia and air pollution and maybe food production, which we are more recently investigating, and other metrics which I can keep bringing up, you might realize that we have a different sense of how we measure things. And so if we're trying to figure out ways to alter the existing industry, we need to also update our metrics and standards. And other places, they do that. We are more recently in the States trying to do that as well. But in the Netherlands, for instance, they already have, I believe, was it Netherlands or Switzerland? But they have a lab that they call it indoor environmental data lab. And so they measure all sorts of things, not in isolation, but in comparison to each other, metrics that are very complex. Nevertheless, they can actually start creating variables that they are having different value based on what we are looking to see. And so I assume that we know, most of us, or the ones that they are around the building sciences, this famous mantra about 90% of our time that we spend indoors. It's very interesting to consider these kind of things. And then we also know that for average, 40% of the energy is consumed by heating, cooling, and ventilation systems in the States and other places. But in reality, the one thing that we don't discuss necessarily is that, is it the same for all sorts of buildings? Is it the same when the environmental conditions are favorable? And if it's so, how significant it could be the percentage of time we spend indoors? So for instance, if we have natural ventilation, does it really matter that 90% of our time we spend indoors? Do we use the same energy for regulating our space while we live in there? That's kind of the questions that brought me into developing this kind of vertical ceramic wall system that I was talking to. And so within this context, my research was focused to investigate a reinterpretation of the functional scope of the building envelope as a device to mediate both exterior and interior fields of atmospheric pollution. Conceptualized as the combination of mechanical apparatus with the effectiveness, sensitivity, and interactivity of a biological organism, the exterior wall section would serve as a site of inquiry towards the potential remediation of urban air streams. What you see here is some of the work that I produced for my PhD, analysis of indoor systems, outdoor systems, active, passive, standalone, integrated, and so on. There is a lot of these systems for the indoors. There are only maybe one or two of them for the outdoors, which is active and not a facade green that it doesn't perform in any other way except from evapotranspiration and bringing temperatures down into buildings. And what I was suggesting is that I'm using this in-between system that is an envelope system. And so in my work, I've been analyzing existing systems in terms of materiality and why do we need to fabricate and market all these systems as such as to become a product, a commodity. Do we need to have all these materials for these kind of systems? After all, we only need three major components: air, water, and energy. That's the three environmental flows that if we combine together, we can actually create a functional wall, and of course we need the plants. Everything else is supplementary. They're either there to withhold another system or tunnel the water or channel the energy or whatever that might be. But we don't necessarily need all these different materials. And that's what I was trying to show there, that for the system that I'm proposing, we can minimize them to the absolutely necessary. if we don't consider them as a product, as a commodity, as something that we need to sell to clients. If, for instance, we can substitute in several regions of the world a component that we're already using for build our houses, our indoor spaces. So if we could substitute brick with something that would be a functional new brick, you could actually get into minimizing this material use. And of course, I was trying to do these physical experiments because, as I said, our PhD was about applied research. And then guess what? By the moment that I was ready to get inside the lab, coronavirus was there. And they kicked me out of my office and my lab in one night. Even my passport stayed in there, and I had to get special permit to go get my passport to go back to Europe for coronavirus period. So I transformed all my research into digital, upgraded my diagrams. We have already experimented in a different scale with human subjects. As you can see, the diagrams were talking about this kind of data that I was trying to get out of these devices, the kind of environmental airflow chambers that I was trying to achieve here. I have already defined the variables that I was trying to measure, the different variables that I was trying to measure, and it was mostly related to airflow, as you can see. And of course, then I had to transform all my research into a digital chamber. And so I was struggling for the last 3 years to transform everything into a computational fluid dynamic environment, turning all my work into CFD, analyzing some of these brick walls, trying to define what kind of digital variables I should include into the computational fluid dynamics. So correlate air pollution with wind speed and temperature relative humidity in 3 different cities. One of them was in Athens, the other one was Mexico City, and the third was New Delhi, or Delhi in India, the worst air pollution environment by far in the world. And the reason is because they have all these mountains surrounding the city that they don't allow the kind of wind streams to disperse the pollutants around and maybe get rid of some of these concentrations. And I'm not going to get into a lot of details about CFD, but I was mostly thinking I'm going to focus a little bit on this diagram up here, which was a matrix about 3 different speeds, air velocities going through this component of the wall, per porosity of growing media, trying to identify the correct morphology, or a more optimized morphology, let's say. And as you can see down there, 4 different types of structures compared through heat diagrams, trying to identify how many I might need per ASRAE metrics, just to make sure that whatever I'm describing here is not way out of context. And with that, I don't want to scare you with all these metrics and numbers, but the idea is that everything was here. And then, of course, after all this work, and all this maybe a decade of work, I was thinking, what am I doing as an architect? How I'm kind of incorporating all this work into the rest of my professional activities. And this is where United Atmospheres came, which, if you can bear with me and go really quickly through the statement here. It's in architecture, the term atmosphere refers to the overall sensory experience of space, including its physical, emotional, and psychological qualities. It is a holistic concept that considers the interplay of various factors, such as lighting, materials, textures, sounds, temperature, and spatial engagement in creating a particular ambience of mood. Atmosphere is an essential aspect of architectural design, as it can be significantly influence how people experience and interact with a space. Architects often use atmosphere as a design tool to evoke specific emotions, such as tranquility, excitement, or and communicate the intended purpose of a space. Atmospheres can be shaped by a range of factors, including architectural and social dynamics. We recognize that a hostile atmosphere can negatively impact people's mental and physical health, while a friendly atmosphere can promote comfort and inclusion. Therefore, we believe in creating atmospheres that are welcoming, inclusive, and supportive of everyone. So United Atmospheres is this kind of studio that tries to create healthy and sustainable living environments for all. At its core, this concept recognizes the intersection of political, architectural, and scientific atmospheres with the need of a minimum global humanitarian and environmental consensus around space quality, air pollution, and health for urban and indoor environments, among other functions. We also believe that clean air is a fundamental human right, and all individuals have the right to breathe air free from harmful pollutants. And to achieve this, we must prioritize the health and well-being of people and the planet over economic interests. Scientific research is essential in understanding the impact of air pollution on human health and environment. We advocate for continued research and innovative technology solutions to promote clean air. More or less, this is what we believe in the work that I'm doing with my team members. And in that aspect, that's what I was trying to teach my GSAP students last year as well. The studio was named after the class was named under the studio name, where I was trying to give back to the community some of the knowledge that I have gained over the last few years, because I believe that it's essential for young designers as yourselves to be educated around these subjects. I think it's going to become a necessity a few more years for everyone to at least know roughly what kind of concentrations we have inside the spaces that we trying to synthesize and evaluate. And in that sense, I was also collaborating with a startup company that's called Future Air, bringing sensors inside the Avery Hill building in Colombia, measuring the dean's office atmosphere, the classroom, and other places. Unfortunately, I cannot disclose what was going on with the pollutants in there, but maybe you can see it a little bit in the diagrams. Trying to study urban canyons inside the city, what kind of pollutants they have, different settings, educate the kids around these kind of students, about these kind of subjects, studying their own personal spaces by getting devices and measuring what's going on and problematic points and what they can do about it. And then at the end, trying to prototype a new type of not so-called green wall, as we were naming it back then, something that's going to be disintegrated into what we are calling the seeds of air purification. So same system as you saw in the green wall, but in isolated modules that they were hanging from spaces with other benefits. By the way, functional system prototype in less than 15 weeks of the semester. Of course, not very well adjusted. At some point, if we not keep track of the system, the plans would start dying, but the proof of evidence is here. It needs more funding, I guess. That's the idea. And with that, I was also teaching my students and the rest of the community about other subjects like air quality and inequality. And so what do we mean by inequality? And the concept of air quality, we know what it is, but the index is usually conveyed with oversimplified numbers and color-based diagrams and standards that do not account for different ethnic groups, sex, and other characteristics of diversified human subjects. In contrast, recent studies have indicated that race appears to be a crucial factor in pollution exposure patterns, partly due to past discriminatory policy making. And that's what you see here in Auckland. A few decades ago, somebody tried to identify these regions as red line regions. For those of you that you don't know the term, it's associated with funding from institutions, either banks or kind of public institutions. Whatever was red-lined, it was considered a little bit more of a risk. Usually, the communities that you would see around, they were communities, either privileged communities, communities of people of color or other things. They were not getting enough funding, and then all sorts of pollutant emission activities were approaching the area, creating what you see today. Of course, as I said before, this is not the only thing that I do. I'm not only teaching or doing buildings or studying around these subjects, I'm also writing about them in different media, more scientific, as you can see, presenting different conferences. and less scientific, about trying to educate a broader kind of audience. And some of them, they are doing great. Some of them, they've been received quite well. People were interested about it. Some of them have been translated into 3 different languages, which was amazing to me. I never expected that it would happen. And some of them, they have been turned into exhibitions. And that's another interesting thing for me. The work that I'm trying to do with our studio and the collaborators that I have is a form of what I describe as an active form of scholarship. So it's not only about maybe teaching or not only about making buildings, it's not only about doing research, it's about trying to bring all the work that I do into creating some sort of a new entry, a new step for moving forward with the overall theme, if I can describe that as I would like to. And so exhibitions is a big part of it. And so I'm collaborating with metal manufacturers in order to create this sample of green wall, but also show the metrics and start educating people. What you see here is in the Tallinn Biennial a year ago, I believe, Stephanie, maybe. One of the pieces over there, I've been also working with the bottles material that I was saying to the Oslo Triennial a couple of years ago. Onassis Foundation in Athens, Greece, a storefront for art and architecture. Istanbul Design Biennial, all related to human subjects, air pollution, and these kind of themes. And of course, discussing all these subjects into broader audiences. ESO conference about indoor spaces in Greece. I don't know why the video doesn't play, but that's not the point here. You see me live, that's good enough, I guess. Tallinn, again, broader audience, not just for the architects. It's very important to me, all this knowledge to be transferred to the audiences that they might start thinking about these subjects. UN Sense, the UN Studio Research Department, discussing about how we can incorporate these kind of systems into some of their new buildings. And of course, during the pandemic years, which I was back in Greece, I was serving as a scientific advisor of the mayor of the city of Chania in Crete, the island, trying to persuade them how we can alter a few things, maybe design, digital design a few urban infrastructure, eventually with a goal to start pushing them towards green infrastructure in the city, which I've never managed to do, but at least I was trying. And then also serving in the Center of Mediterranean Architecture, which is an old Venetian arsenal in the city, as an architectural committee member. And Anthony was there a couple of years ago. It will be missed. He was a dear family friend. It made us the honor to be there to give us an amazing lecture 3 years ago. We still every day think about him. I know that's very recent, but his texts are going to remain among us, at least. World Health Organization as well, trying to do different kinds of workshops in the same place, and also serving as part of different committees in different magazines related to this kind of work. And guess what? This is how my new website would look like one day, but it's not there yet. It's almost there. We have the front end. Now we have to finish the back end. And at some point, I might be able to start uploading my projects as well. And with that, I don't want to scare you more with air pollutants. I will leave it open for you and any questions you might have. Thank you so much.
Questions?
And please.
How can a concept like this be introduced into more, not necessarily in a wall, but more into a group kind of intervention?
So every time that we're trying to implement one of the systems into our overall massing, we are talking about space occupation. It's either going to be a mechanical floor or a system that gets a space, or it might be a void to get a few pipes through. I guess the way that you can do it is trying to define what you're trying to get out of the system. The way that I did it, I was trying to substitute the kind of envelope component with this new kind of wall. And so instead of using excess space for introducing this kind of system, I was trying to implement this new system into environments that could actually accommodate it based on their kind of biome conditions, temperature, humidity, and so on. The way that I would try to introduce this kind of systems, it doesn't matter if it's going to be in the roof, or if it's going to be in the wall, or if it's going to be the floor, but it has to do with the overall idea about passive and active systems. So if you're designing something that has a huge floor plate, zero articulation, like the skyscrapers that we see in New York City, it's going to be very difficult to avoid having active systems. And what I mean by that is, imagine that you have this huge floor plate, zero articulation, and then you're trying to get natural ventilation or lighting or, I don't know, water conditions to the core of this floor plate. It's not going to happen. That's why we need to figure out from the beginning of what we are doing, what is going to be the purpose of our building, what kind of approach we're going to use, how we're going to study the environment around this building, and then act accordingly. If it's a small scale, you can use a system like this into a rooftop, a green roof, or whatever that might be, if you start thinking in parallel with what we are trying to achieve. I guess, yes, I know that in a lot of places they use green rooftops to insulate mostly buildings and also have a productive rooftop in terms of food production maybe. But we also need to consider other variables every time. So I know, for instance, there is a great study from Columbia University back in 10 years ago, where they were studying the availability of rooftops for this kind of green roofs, but they were also mentioning things about how heavy the soil should be for avoiding collapsing, what kind of retrofits we need to accommodate, what kind of insulation we need to have in terms of humidity and water not going through. And there are people that are studying all these things. For instance, I know that Professor Paul Mankiewicz, he's a biologist, but he's creating what he's called Gaia soil, which is a mixture of plastic byproducts with soil that make all these aggregates being quite lighter. You can use them in the rooftops, get a lot of water to be sustained from rainstorms, and create these green roofs that you are talking about. So incorporating living systems into the building environment, it's not going to be difficult if we have the mindset to start thinking about these things in an entirely different way. And I conclude with that, if we keep thinking about architecture as we were doing in the past few decades, let's do our math, let's do our envelope, let's do whatever, the overall aesthetics of the thing, and then let's call the mechanical engineers to solve all these issues for us, it's not going to happen. We need to consolidate, we need to consult with them as a group from the beginning, specify our intentions, and start solving more complex systems as a group. I believe we have moved way beyond the era of the Renaissance, that the master architect knew exactly what he has to do to resolve all the issues. These days, our buildings are becoming so much more complex that it's impossible to synthesize them, design them in isolation. Only the mechanical systems have become, for whatever, 1% of the overall budget, roughly to 20 to 40%, depending on the type of building, of the overall budget of architecture these days. So I guess hopefully that somehow gives you a mindset of how you should start thinking about these kind of questions.
So you presented your work in front of different types of audiences. You mentioned earlier, as part of your atmosphere statement, that you should look beyond kind of the economic necessities or the economic realities and start to be more inclusive and holistic about like, what we really mean by Earth pollution. In your experience, what has been, or let's see, what's been the best way to convince people to try, for instance, some of these new technologies? Like, is it saying that like, you may spend more money on the front end, but you end up saving a lot of stuff, or is it that, you know, when people know about all the different sizes of particulates and et cetera? So, like, what makes people care more?
Well, I know that many people in this country, they consider me a radical leftist or whatever, almost being a communist. But I guess when I took a kind of course in my master's degree at Pratt, I was called environmental economics. At the beginning, I was kind of stunned by the idea. What do you mean by environmental economics? Do we actually measure the performance of a forest? Do we give value to these things? Why do we need to measure them in dollar value? I was so annoyed by the overall concept, but then I realized that the idea was that we're actually trying to visualize metrics around these subjects. And so if we actually manage to achieve, and I'm not suggesting we should get outside of the overall socioeconomic structures that we currently call our societies. I don't know any better system yet from what we call capitalism, although the extreme versions of it are a little bit questionable for me. But if we start thinking about how we can add different types of value that they're going to be related or transformed or translated into dollar amounts, as they do in environmental economics, that's one way you can do it. In my opinion, if you start translating that, guess what, guys? Maybe you don't see it today, but if you spend 20 years having lower performance into your working spaces because you have this extremely polluted air, and then you spend another 2 years going in and out in hospitals over the kind of range of 20 years, and then at the end of your lifetime, you also shrink your lifeline by a couple of more years, which is not entirely visible now, but eventually we're going to get into the point that you can measure all this kind of physiology history, then you can give them a number, and that will respect. I know that they don't necessarily, people see it this way. You might see a lot of greenwashing about how, this wall or this product is doing a lot much better than this, or this new HVAC building has like, the HVAC system, it has like 5 or 10% reduction in energy. Guess what? It might be using 10 times more raw material to get there, or it might come from the other side of the world, in Japan, to just get here. Do we measure embodied energy? Will we measure all these other things? Where are all the negative externalities? So we end up having a comparison between mechanical and, I don't know, natural systems with the metrics of the mechanical systems, which cannot possibly be compared. You're going to lose every single time. But if you start thinking like in a different mindset that, so we use this HVAC that they currently burn fossil fuel to regulate indoor space, and then we spew even more air pollutants outside by this burning, which we have to re-regulate again into this vicious cycle of recirculating air pollutants. How do we measure all these things, and why we do not consider them as negative externalities of these kind of systems? Then yes, you can promote these kind of systems in an entirely different way, in my opinion. Does this come close to replying to your question?
Yeah, I think I have time for one more question.
Andreas, thank you for a really important and really well-presented lecture. I want to ask you about your evolution as a professional and the people who have mattered to you along the way, from the time you were in school training to be an architect to where you are now. What is that circle of people around you? Who are they, and are there mentors there, and what kind of people are they now as you get to this point in your professional development?
So I have to say that students very often are quite important to me, since they constantly ask questions that you would maybe take for granted and you might never thought about it, but maybe through their first steps into the discipline, they ask very interesting questions that you would never think, because you take as your mind has a specific setup after all these years of experience education. And that was, to be honest, the reason why I went back from a practitioner to start my master's degree. At some point, I felt like I was recirculating around my axis without inventing anything new, without educating myself. So yes, Anna Dyson, although we have a rough relationship sometimes, she was my PhD advisor and a mentor to me. Imagine that Anna is currently at Yale. We're still trying to collaborate. She moved in the middle of my PhD. Imagine the version of Steve Jobs into an architectural science person. Difficult but brilliant. So she's a great mentor. A lot of people around the industry, which I constantly consult and discuss with them, evolution about mechanical systems, systems of production. The company that you saw in Greece, they have all sorts of digital fabrication methods. They have different, I believe, 80 different types of prototyping only for metal. They export all these products in Europe, which is quite rare for a small country like Greece. Having a company that gets a huge outreach, I'm constantly collaborating with them. So I'm trying constantly to bridge the kind of more educational academic environment with a more practical into one cohesive way of integrating and interacting. And so I have a lot of people that I'm talking for there, and developers more recently. I'm trying to bring all these projects into people that actually, stakeholders that can actually start pushing things forward. And of course, I'm applying to grants now that I have a little bit more time. Because during my PhD years was a little bit more difficult, although I got a quite big internal grant, roughly $400,000, which supported my last 2.5 years of research. But now I'm trying also to apply to NSF, continue with the funding search. Sometimes it will be difficult depending on the kind of body of students you have to proceed with the research, and that's why I'm trying to keep my collaborations with Columbia and Yale and all these other institutions. And I'm always open to other collaborations. And so it's a range of people that I'm trying to get in contact with. Even the mayor of the city, as I was saying before, of Chania, because I truly believe that politicians could make a difference if they start thinking somehow else from not only be revoted and re-elected.
Names are important.
Yes,
Thank
they
you.
are. Thank you so much. Thank you so much. Thank you so much for inviting me. It was great to have such a nice audience.
Cool. That was great.